This video is on multiplication rule without independence. So these are dependent events. What happened before has an effect on what happens after, is a way to think about it. This is also known as the multiplication rule without replacement. I would recommend that if you did not already watch the video and complete the activity for multiplication rule with independence, that you complete that now. So the dependent events, what we're talking about is that the outcomes depend on what happened before that. So in this formula, you can see that the probability of A and B, and that upside down U is our and. So you can also see it as this. The probability of A and B is, in this case, the probability of A given what happened with, and then probability of B given what happened with A. So this B given A, that's what this is saying. B given A. So that's where it depends on what happened. So what we are going to get with our second event, B, is going to depend on what happened with our first event. So I'm going to demonstrate that. And this is just a little note in your PowerPoint that vertical bar means given. So the probability that B occurs given that A has already occurred. So again, we're talking about multiple events, and this is not like with the coin flip where it doesn't matter what happened before. You always have a 50% chance of flipping a heads or tails. And so that's not going to make they're independent events. This is where we have dependent events. So as an example, I have a deck of cards and I'm not going to replace them. So if I randomly select a black card and I take it out of the deck, that's going to reduce the number of black cards that are left. It's going to change the probability. So if I select a card and that card started out as in a deck of cards, we have 26 that are black, right? There's 52 cards total. And then for my red, I also have 26. And so 26 plus 26 is 52. So that's where I got that denominator there. So 26 over 52, that would also be 0.5. That would be the other way to think about that, 0.5. That's our probability. When we first start, that's our probability of getting a black or a red card. Now, let's say that we do get a black card the first time. The probability the first time that we would get a black card was this 0.50. But we didn't replace it. So now the probability of getting a black card has gone down, both for the number of black cards that are left, because we have 26 minus 1, because we took out a black card, right? Because that was our selection. We got a black card the first time. And the total amount went down because we took a card out of the total amount as well, because we took a black card out. So that's now going to be 51. So when you calculate that, you're looking at a different probability here. So the first time we had 26 over 52. The second time we had 25 over 51. And I went ahead and I just multiplied it across and then divided it. You could do this different ways. So we could say 26 divided by 52, and that's going to be our 0.50. And then we can calculate 25 divided by 51, and that's going to be, so now we're multiplying 0.49. And I get 0.245. So it's just slightly lower. If you look back at the previous example with the coins, the probability has changed a little bit. It's a little bit less likely that I'm going to get another black card because I've taken a black card out of the deck. I'm no longer looking at the same probability. That's what this idea is about, this rule without replacement. And so we could continue going through this. We could look at how this changes. And so I'm going to clear this off just so that this is clear now. So now, if I wanted to select a card the first time I get a black, that was my 50% right there. So at 0.5 would be my probability as a proportion. And then this time, if I select a red card, what's my probability of getting a red card? The number of red cards are actually the same in the deck, right? So I still have 26 red cards because my red card didn't change. I didn't take out a red card. I took out a black card here. So red stays the same, but I still only have 51 cards left like I did for the last one. So it's slightly different. And now you'll see that it's slightly higher because I have more red cards left in comparison to black cards. And if I keep doing this, you can see that, again, the probability of getting a red and then a black, it's going to be slightly higher for getting that because the black is unchanged. I still have 26 out of 51, so getting that the second time is a little bit higher probability. But if I go to 2 reds, I'm going to get the probability of 2 reds is going to be slightly lower because I've already taken out a red that first time. So that's that idea of without replacement. So if we didn't put the card back in, that reduces the amount that's left over. So this value right here is the probability of B, which is getting us another red card, given what already happened with A, where we took out a red card. And so that's where we get this adjusted number, is that this is lower by 1 red card, and that's lower by 1 red card. So again, I have some practice questions for you for this concept, and then just reach out if you have any questions on that.